So I guess we are live, are we? So yes. So hello guys, welcome back. So today I'm starting off a new. Hello guys. Today I'm starting off a new journey. Today I'm going to solve a few problems on the go. Okay. In this channel, I'm going to give you a few solutions from Irido problems and some Croto problems. Right. So why I'm starting this? Okay. Before we go anywhere else, I want you guys to remember one thing: stay at home, stay safe. There's a pandemic going on right now and it's reaching the second wave, so I want all of you guys to stay at home, close, be be like this guy. In short, stay at home on bus. Don't get distracted, just stay safe. And while you're staying at home and staying safe, crack IIT-JEE with India's largest platform, which is an academy. Yes, get the plus subscription using the code NSS1 to get extra benefits. Get the subscription right away. So this is how the app will look. An Academy Learning app. It's pretty cool. It has two half circles there. And hi guys, about me, little about me. I'm N Srikanth. I did my BTech from IIT Kharagpur. I have an AIR of 385. I've been guiding you guys for the last 4+ years. And yes, you guys call me human calculator. We'll know why with a few tricks I'll tell you on the way. I'm a Sunrisers fan and DC is equally marvelous. हाँ मैं DC का बड़ा fan हूँ Joker का. So anything you want to say, feel free to hit the comment section below. All right. And don't forget to like this video, share this video, subscribe to the channel. Let's crack JE. All right. So today we'll start off. This is a new thing. Today the first topic is mechanics. I thought I'll start with whatever is the first chapter in the book. So solutions to Iridov and Proto by N Srikanth. This is here, guys. हेलो गिरीश गौरव वेलकम. सो आर यू रेडी? मतलब एकदम थोड़ा इजी क्वेश्चन है. क्रोटो का क्वेश्चन थोड़ा लंबा है. So let's see if we can finish it. Let's see how far we go. So this is the image. This are the two books. They're supposed to be the toughest books which are available here. I'm good, Girish Gaurav. How are you? So these are the toughest books. So let me tell you why I started this. All right, just give me one page. Let me tell you why I started. I thought this is a good idea, especially right now, because I know all of you guys. A lot of you guys are facing trouble as to understanding which book to do, how to solve problems and all. Okay, but this particular solutions I wanted to keep in mind, having one saying which I always believe, that one good problem is better than 100 average problems. One good problem is always better than 100 average problems. So especially when you're writing exam like IIT-JEE. So I thought I'll put at least a few questions on the go, so that one good problem you'll understand many more tricks or many more ways of approaching a problem than taking 100 average problems. We just have one formula, उसको use करते जाओ, you'll get the answer. तो वो क्या है? मतलब it won't work that way. That is not the best way to go about it. So that's why I thought I'll bring in a few good problems which I think are like conceptually good. Like there are some ideas which will strike you well with those questions. So here we are. So that's what I always believe, and this I think helped me when I was preparing for JE also, because like I didn't really work 100 problems a day. It was always doing a few good problems and getting lot of concept from that, then doing a quick test. Once you are done with this, like do like 3 4 good problems a day, then have a test with average problems, like 20 questions in 1 hour type test. A test plus a few good problems, maybe 2 or 3 all will do. Good problems, ये अगर तुम next 2 months करोगे, 3 months, your general understanding of the exam will improve like crazy, I'm telling you. तो बस इतने, इससे ज़्यादा भी ज़रूरत नहीं है. You can take sets of these 2 3 good problems from maybe एक like this, generally this is HC Verma के last 20 and maybe Irido problems. So 1 or 2 a day also will do, but if you're really aiming for a good rank. Yes, exactly, Garish. That is the point. One good question will help you not only with understanding all the concepts which are around, but also how to link them together. It's a linking that is where IIT-JEE is different from every other exam, where the concept link between one question and the other part of the question, how they are linked. It's a multiple concept problem most of them. So that is why I'm here to give you just a few ones. Today, I think I put a few 4 or 5 problems. So definitely don't forget to share this video everywhere so that everyone who wants to get like a good understanding of how to crack the exam can refer to this video. All right. So let's start off with a nice question. Look at this. ये क्या मस्त question है. दिखने में तो ऐसे लग रहा है. It's looking pretty crazy. Horizontal plane supports a stationary vertical cylinder. So this is a stationary vertical cylinder. ये क्या है? ये एकदम stationary है. Fixed. So this part is fixed. So ring a disc A attached to the cylinder by horizontal thread AB of length L0. ये initial length L0 है. ऊपर से दिख रहा है. This is what is given to us. All right. So an initial velocity V naught is given to this perpendicular. दिखने में clearly दिख रहा है. It is perpendicular as shown in the figure. Right. How long will it move along the plane until it strikes against the cylinder? The friction is assumed to be absent. So इस question में क्या है? So let's just oh, I think you cannot see the question completely. Give me one moment. Just give me one moment, guys. I'm saying. Let's get back to it. So it is imparted discussion. So इसमें what are the inferences we are going to find out? Let's see. Okay. I'll tell you what are the smart points which you have to understand from the given question. अच्छा, तो ठीक है. तो इसमें starting just give me one moment. Check us. All right. Awesome. Now let's solve this problem. Take. Hello, Sairam Garu. Good evening, Amma. So in this given question, the cylinder is initially given. So what are the key points we have to understand? That the thread is always having some tension here because this particle will have some mass. So the moment as it starts moving in the circle, in this whatever path is given, there will be a tension inside. वो बात तो clear है. That is making the particle move in a curved path till it hits the cylinder. Okay. So there is tension in the string, which causes the particle's motion to be in this kind of form, which makes the particle move, makes particle move along the path, move along the string. String constraint की तरह हो जाएगा यहाँ पे. All right. So one more thing you have to understand: the tension is perpendicular to velocity. Tension is perpendicular to the velocity. All right. So tension is not going to. So initially there will not be any change in speed due to tension. What will tension do? Tension only changes direction. Tension only changes direction. All right. So it changes direction, but the component of tension along the velocity is zero, right? So the component of tension along velocity is zero, so the velocity will not change. Tension only changes direction, it does not change speed. This is always the case whenever a particle moves in a path constrained by string. मतलब string के कारण कोई सा भी path में move हो रहा है. Most of the cases it will be unless and until an external body is trying to move the tension, move the particle, like ऐसे tension अगर हो गया, then it's a different case. But if it's starting vertical, when it starts vertical it will always remain vertical. Getting it? So the tension here it does not change speed. So the speed of the particle will always remain v naught. The speed of the particle is always. This is the first observation we have to understand by using just the concept of string. What is the string doing? From that we can understand the speed will remain same. अच्छा, अब तो एक part खत्म हो गया. The first part we understood. The speed of the particle is constant. Speed of particle remains v naught, which is constant. All right. So this is the main thing. हिंदी फॉर बेटर अंडरस्टैंडिंग ऑल राइट, ठीक है यार, मतलब स्पीड हमेशा सेम रहेगा, ठीक है, स्पीड बदलेगा नहीं यहाँ पे. द प्रॉब्लम इज आई एम वेरी बैड एट हिंदी, सो पार्डन में हिंदी. लेट्स सी, लेट्स सी, चलो ट्राई करता हूँ हिंदी में. पार्टिकल का स्पीड नहीं बढ़ेगा क्योंकि टेंशन वर्क नहीं कर रहा है. टेंशन इज परपेंडिकुलर टू वेलोसिटी ऑलवेज. तो वर्क डन बाय टेंशन कितना होगा, शून्य हो जाएगा. तो स्पीड सेम रहेगा, काइनेटिक एनर्जी विल रिमेन सेम. ठीक है, अच्छा समझ में आ गया. तो अब नाउ लेट्स सी हाउ फास्ट इट विल रोटेट, मतलब व्हाट इज द टोटल स्ट्रिप इट कवर्स, इट विल कवर एंगल, राइट. तो हमेशा when it's going like this, what is it covering, it is covering angle. हमेशा एंगल कवर कर रहा है, राइट. सो वन मोमेंट गाइस. अच्छा, तो इसमें हमें क्या, लेट्स गेट बैक नाउ, आई थिंक वी हैव सॉर्टेड द प्रॉब्लम. तो हाँ, तो यहाँ पे स्पीड हमेशा सेम रहेगा यार. जस्ट गिव मी 5 minutes. ऑलराइट, आई थिंक वी गुड टू गो, आर वी? हाँ हाँ भाई, चलो लेट्स गेट बैक. अब तो सेट हो गया है इशू. थैंक यू फॉर बीइंग पेशेंट गाइस, मतलब अब सॉल्व करेंगे. So one thing we know here is that the velocity of the body will remain, velocity of particle is v naught always. तो मतलब जैसे कि when it starts rotating inside, as it starts winding in, the radius will keep decreasing, the length, the separation from the center will keep decreasing. As it keeps winding in, the omega will keep increasing because speed is same and r is the distance is reducing. Omega will keep increasing, right? Getting it? So omega will increase, so time उसके हिसाब से थोड़ा बदलता जाएगा. So how do we calculate that? For that, let's take a small example and solve. At an angle theta लेते हैं. At an angle theta, at that instant the thread will be like this and the velocity of the particle will be this way. ये हमेशा v naught रहेगा. So at this particular instant, if the angle is increasing by d theta, it is the rate at which the angle is changing, right? And what is the rate at which the angle is changing? The rate of change of angle delta theta is nothing but d theta by dt, which is equal to omega. मतलब हमेशा ये omega होगा. It will depend on this length L. Will be equal to v naught by L. All right. तो L क्या है? L is the distance between this end to the from B to A. From B से जैसे start हुआ A तक. So as the point keeps changing, this point the length will keep changing to L. So at an angle theta, what is the total length which got reduced from here? Initial length L naught था, ठीक है. और यहाँ से जब ये थीटा एंगल गया, टेक इट, इफ इट इज कवर्ड थीटा एंगल हियर, जब ऐसा हो गया, तो व्हाट इज द चेंज इन आर्क लेंथ हियर? दिस लेंथ इज इक्वल टू थीटा इंटू आर. ऑल राइट. तो मतलब यहाँ पे अब लेंथ कितना हो जाएगा? लेंथ विल बी इक्वल टू एल नॉट, द टोटल लेंथ, माइनस थीटा इंटू आर. So this is the key concept here, guys. L is equal to L naught minus theta into R. This is the first point. Or d theta by dt is the omega. Omega is the rate at which the angle is changing. अब तो ये हो गया, लेंथ ऐसे बदल रहा है तो we'll just equate this with 2. I'll put 1 and 2 together. तो क्या हो गया, d theta by dt is equal to omega, which is equal to v naught by L naught minus theta r. Yes, finally. यार ये पहले क्या हुआ ना, this eraser stopped working. When you're solving Kroto problems without eraser, then it is not good at all. ठीक है. Lagging हो रहा है क्या? I can hear myself properly, man. I'm able to hear myself perfectly fine as things stand. All right, so ये आ गया. Now you just solve it. मतलब कैसे solve करें मतलब? So let's see what is the total angle. तो हमें v final time चाहिए ना? Time चाहिए तो we can just integrate this value. We'll get the answer. ठीक. क्या आ गया है इसमें? कुछ नहीं है. d theta by dt is equal to v naught by L naught minus theta r. तो इसको इस साइड भेज दो v naught, तो everything will send it to the other side and only time to this. So d theta into L naught minus theta r by v naught is equal to dt. तो इंटीग्रेट करो दोनों साइड्स. अब इसके लिए लिमिट 0 to टोटल टाइम हो गया. तो यहाँ पे लिमिट कहाँ से कहाँ तक कवर है? व्हाट इज द थीटा का रेंज? थीटा स्टार्ट्स एट 0 बिकॉज इनिशियल 0 है, बट थीटा इज द नंबर ऑफ theta basically is the angle covered by the thread. Angle covered by the thread. समझ में आ रहा है ना? अब theta is the total angle which it surrounds. The thread is bounding around the cylinder, covering an angle theta. So we can, by using the arc length concept, we can simply say theta into r will be equal to L naught. तो theta का final कितना होगा? It will be equal to L naught by r. इतना ही है यार, मतलब सिंपल सी बात. All right, so let's just solve it. I'll send this to the left side. So I will write saying integration of dt from 0 to t is t. T will be equal to 1 by v naught. 1 by v naught common ले लिया. L naught into d theta, तो L naught theta हो गया, minus r into theta d theta कितना होगा? बस यही है आंसर. इसका वैल्यू कितना होगा? 1 by v naught into L naught into theta is L naught by r into theta, बस theta लिख देते, minus r into theta square by 2, 0 to L. हो गई यार बात, बस इतना ही है. That's it. What is the answer we getting? L naught into L naught into L naught. So L naught square हो गया by R V naught minus R into, ये तो आधा हो गया मतलब सीधा L square L naught square by 2 R naught square. So into V naught. V naught is already there. So by using the whole thing we get time is equal to R L naught square by 2 R L naught square by 2 R. This is the answer, guys. तो मतलब हो गया ना. ग्रेट जॉब. इट्स बीन अ ग्रेट, वेरी गुड फर्स्ट पार्ट. आई होप यू अंडरस्टूड दिस. नमस्कारम गुरु गारू. हेलो सिद्धार्थ यादव, वेलकम. तो विच स्टेट डू आई बिलोंग? आई एम फ्रॉम हैदराबाद मैन. आई एम फ्रॉम हैदराबाद, आंध्र प्रदेश, एपी, तेलंगाना बेसिकली. आंध्र प्रदेश से आदत हो गया, तेलंगाना से हूँ मैं. ऑलराइट. All right, now for the next Irodov problem, which is problem number 1.178. So today we are solving Irodov problems. I hope you like the first solution. I know it's been a little slow. There was a little technical issue with the pen. अब ये जो है ना वैक्यूम टैबलेट, इसका पेन से छोटा इश्यू हुआ था. So that's why we had to go from this. Love from Bihar. You too, bro. Nice. So now a rocket ejects a steady jet whose velocity is equal to u relative to the rocket, and the gas discharge rate equals mu kg per second. Demonstrate that the motion of the rocket, a motion equals in this case takes the form of w is equal. So this is the question. So इसमें क्या है question? Let's solve this. A rocket is being pushed न्यू सेटअप फॉर क्लासेस इज जस्ट मतलब इंटरमीडिएट सेटअप है ये, पीछे ग्रीन स्क्रीन आएगा. So I want to make some animation stuff also eventually. So let's see. As of now, this is just a temporary setup. So there's exhaust going out at the rate of mu kg per second. All right, with a speed, relative speed of u. Okay, this is the concept, and this is there's an external force F which is pushing it up. So this is all given external force giving it F upwards along with the discharge of mu which is going down with a relative velocity of u meters per second. So one thing we have to understand here is एक simple सा concept, force will be equal to dp by dt, बस इसी से काम हो जाएगा. This is the net external force. F net external is equal to dp by dt. All right. So इसमें एक बहुत simple सा concept से I'll come up with this. Okay. So the total mass of the body, if you assume the total mass of the body is at any instant is equal to m. इसको simple सा I'll try to cover it in as small situation as possible. Let's take the total mass imagination is equal to m. तो ये टोटल मास जो है it is equal to m. Total mass is m, and this is experiencing a force of f upwards. All right. So f will be rate of total change in momentum of the whole system. So whole system mass m का momentum change will be a. So total change in momentum of the total mass system will be how much? Now we will figure this out. One thing the total mass is initially going up with acceleration a. तो ये जो mass m है उसका acceleration a हो गया. Along with this, इसको सिंपली पहले ये सॉल्व करता हूँ. यू कैन जस्ट राइट m इंटू डी वी बाई डी टी प्लस डी एम बाई डी टी इंटू वी. ये v जो क्या है, ये v क्या होता है, ये v रिलेटिव होता है. मतलब हाउ डू वी गेट दिस? इमेजिन, मतलब इमेजिनेशन से एवरीथिंग विल बिकम क्लियर. v is v relative. Suppose you are going horizontally with some speed. Okay, you are going horizontally with some speed and you're dropping some body from your car. When you're drawing and you're dropping something in your car. When you drop something, your speed will not increase. Remember this. When you drop something, your speed will not decrease. Getting it? Because relative velocity से के कारण ही there will be extra. But if you throw something behind you, you're going in a car, but you throw something in the opposite direction, then your speed will increase. So that is why don't try to confuse yourself with any formula. Just you can understand what is this v here. It can be velocity of this mu kg per second हो रहा है ना. Simply, if you want to solve the problem, you can understand it this way. dm by dt is nothing but mu. Mu आ रहा है. But what is mu useful for? That speed with which it is coming out, the speed of the exhaust. So that speed of exhaust is given as u relative is equal to u, and we also realized that relative velocity is all that matters. तो मतलब अब ज़्यादा सोचने की ज़रूरत नहीं है. तो सिंपली आई विल राइट डी पी बाई डी टी. नाउ वी गॉट क्लैरिटी. मतलब डोंट ओवर थिंक, इट्स सिंपल. मास इंटू एक्सेलरेशन माइनस म्यू इंटू प्लस म्यू इंटू वी. गॉट इट? तो v रिलेटिव तो नेगेटिव डायरेक्शन में है और म्यू भी नेगेटिव है. दोनों मिलाने से ये ma प्लस म्यू भी हो जाएगा बिकॉज बोथ ऑफ देम टुगेदर आर द फोर्स गिवन. इससे सिंपली क्या आ जाएगा? m इंटू ये विल बी इक्वल टू f माइनस म्यू. सिंपल. समझ में आ गया ना? बट ये बहुत सिंपल है ना. दिस इज वेरी सिंपल. सो लेट्स नॉट स्टॉप हियर. All right, let's not stop here. Let's go to another problem which has the same concept. मतलब दो प्रॉब्लम को एक बार में कर रहा है. I don't think anyone has done this on Irodov so far. So let's just do it off. मतलब two in one same session. The flat car of mass m naught is moving in a straight corner. So the both questions are the same. I will derive them and show it to you. But then same है. तो initial इसका mass m naught है. ठीक है. And some sand is falling at the rate of mu kg per second. All right. So इसमें what is the total concept here? The same logic will, if you apply, you will get the same thing. Total force will be equal to dp by dt. which is equal to what? P at any particular point, the mass will be m into acceleration a plus dm by dt into velocity of the body. So mass is increasing here, velocity is v, velocity of the body is v. This is the increase in mass. So this mass is suddenly getting of this velocity, no? This is the velocity of the power of the system. So this much mass is increasing every second, and that mass is getting that velocity constantly. So from this only we can say dm by dt into v. It's the same thing. So if you simplify this formula, what will you get? F is equal to ma plus mu into v. तो इससे क्या आ गया? Same thing again. Acceleration is equal to ma is equal to f minus mu v. Same equation, we get the same thing again as Irodov 1.178. दोनों का एक ही solution है. Alright, so that is cool, right? मतलब Newton's second law. Yes, exactly. Okay. So now let's continue solving it. He is asking us to find the time dependence of velocity. We want to find velocity as a function of time and acceleration as a function of time in this particular question. Actually, दोनों का equation already हो गया है ना. We already solved the equation here. This equation, one equation to rule them all, one equation to solve them, and in knowledge bind them. Find the time dependence of the velocity and acceleration of the flat car in the process of loading. The friction is negligibly small. So friction negligible small है तो simple हो गया. Mass into acceleration is equal to F minus mu v. So we can write m into dv by dt is equal to F minus mu v. तो ये m कहाँ से आ गया भाई? We almost forgot to say what is m. इसका initial mass m naught है and continuously mass is mass as a function of time. Getting it? So mass is a function of time, so it will always be equal to m naught plus mu t in this particular case because the mass is being added. इसको भी सिंप्लीफाई करके यहाँ पे डालना है, तो फ्रॉम दिस विल गेट m naught plus mu t into dv by dt is equal to f minus mu v. तो एक हो गया ना मस्त क्लासिक इक्वेशन आ गया जहाँ पे ये नीचे जाएगा, ये नीचे जाएगा. तो वी कैन ऑल्सो से dv by dt is equal dv by f minus mu v. तो इससे क्या आएगा? dv by f minus mu v will be equal to dt by m naught plus mu t. वाओ, ये हो गया एकदम सुंदर सा इक्वेशन. I hope you understood. I sent dt to the other side along with this so that now I can integrate both of them individually and separately. So t is equal to 0 so t, or v will be from 0 to v. बस सीधी सी बात, कोई टेंशन नहीं है इसमें. तो वन थिंग विल गेट इंटीग्रेशन ऑन दिस साइड, इंटीग्रेशन ऑफ ln f of x a plus bx, द डिनोमिनेटर में b आ जाएगा. वही लॉजिक से यहाँ पे 1 माइनस म्यू टाइम्स ln f माइनस म्यू v इज इक्वल टू, यहाँ पे भी 1 माई म्यू टाइम्स ln m naught plus mu t. तो दिस इज द इक्वेशन विल गेट. यहाँ पे लिमिट्स भी डालना है फ्रॉम 0 टू v. यहाँ पे फ्रॉम t इज इक्वल टू 0 टू t. तो माइनस माइनस ये दोनों कैंसिल हो गए. इफ यू ऑब्जर्व केयरफुली दीज बोथ आर ऑलरेडी गेटिंग कैंसिल, सो आई थिंक वी आर इन फॉर ए वेरी नाइस सिंप्लीफाइड सॉल्यूशन. तो इसमें सिंपल आ जाएगा माइनस ln f माइनस म्यू v minus ln f will be equal to ln m naught plus mu t minus ln m naught. So from this simplification we can also get minus ln. तो माइनस को उल्टा कर देंगे तो विल गेट ln f by f minus mu v is equal to ln m naught plus mu t by m naught. Wow. So this is how simple we get it, right? Hello, Gauransh Goyal. Yes, of course, I remember you from the classes we have with the late night show at Srikanth sir, with Srikanth sir. So definitely, by the way, guys, don't forget to log in today. Also, today I have the class. Yesterday there was some work I went in, and again I became a little late to put the class. So today we have it. Definitely come for the class. Let's all have fun there. All right. So ये solution को let's finish it now. So I'll just e power both sides. So I'll just equate of the equate it all simply. No, एक मिनट रुको. हाँ सेट हो गया. तो इसमें क्या आ जाएगा? तो एफ बाई एफ एफ माइनस म्यू वी इज इक्वल टू एम नॉट प्लस म्यू टी बाई एम. So this is the equation we got. From this we can derive it, right? Yes, be there at 10:30, of course. So now let's solve this. We need to find velocity as a function of time. So I'll send velocity to the other side and everything else I'll bring it to the opposite side. So mf by m naught f by m naught plus mu t is equal to f minus mu v. तो इससे क्या आ जाएगा? I'll send f to the other side again. No, I'll send mu v to the other side. I'll cancel mu this side. From this I'll end up getting the equation mu v. यार ये mu के बाद तुरंत n लिखने का आदत हो गया ना टीचर होके. This is crazy. Seriously. So f minus this whole thing, f minus m naught f by m naught plus mu t, matlab this m naught will get cancelled. So what will we get? We'll get a much nice, wonderful solution saying mu mu t है ना ये यार mu f t by m naught plus mu t. Awesome. इससे velocity क्या आ जाएगा? f into t by m naught plus. This is a solution, guys. This is how we find the velocity of the particle. So it's say one thing you can actually observe. Okay, one thing you can actually observe that this velocity of the body is having a terminal velocity. This is a very similar concept which will happen in a terminal velocity also. If you observe carefully, the same concept happens in terminal velocity. So this will have a terminal velocity. Like if you observe carefully, when t becomes infinity, this velocity will not be infinity. Getting it? So इससे मतलब काफी जोरदार पार्ट आएगा. As t tends to infinity, v will become fixed. As t tends to infinity, v value will become how much? F by mu. So this is only the terminal velocity of the body. So simple ना. तो every movement अगर म्यू kgs is ऐड हो रहा है, म्यू kg ऐड हो रहा है टोटल सिस्टम को, और द सिस्टम इज गोइंग विथ वेलोसिटी v. सो इफ दैट एंटायर म्यू मास शुड गेट द वेलोसिटी v, तो टोटल फोर्स कितना चाहिए उस टाइम पे? म्यू इंटू वी इज ओनली फोर्स. तो जो पूरा फोर्स है वो एकदम वेलोसिटी नए पार्टिकल्स को देने में कम खत्म हो जाएगा. तो दिस इज द टर्मिनल वेलोसिटी. तो जो एक्स्ट्रा फोर्स है स्पीड बढ़ाने के लिए वो बचेगा ही नहीं. तो अल्टीमेटली इट विल रीच टर्मिनल वेलोसिटी. ऑलराइट. ओके. तो इसमें एक मिनट थोड़ा एक और पेज कर दे. वी ऑल्सो हैव टू फाइंड एक्सेलरेशन ना. तो एक्सेलरेशन तो एक स्टेप की बात है. एक बार वेलोसिटी आ गया तो एक्सेलरेशन नेक्स्ट स्टेप में तुरंत हो जाए. वेलोसिटी कितना आया? एफ टी बाई एम नॉट प्लस म्यू टी हो गया. तो एक्सेलरेशन कितना होगा? डी वी बाई डी टी. बस कर लो, होगी बात. एफ ऑफ एक्स बाई जी ऑफ एक्स वाला फंक्शन, तो एफ इंटू एम नॉट प्लस म्यू टी माइनस म्यू इंटू एफ टी बाई एम नॉट प्लस म्यू टी होल स्क्वायर. तो यही होगी बात. म्यू एफ टी कैंसिल. तो इससे क्या आ जाएगा? एक्सेलरेशन विल बी इक्वल टू एफ इंटू एम नॉट बाई एम नॉट प्लस म्यू टी होल स्क्वायर. यस, देयर यू गो गाइस. एकदम इससे crystal clear हो गया. So what I want you guys to understand is just play around. Okay, don't worry too much. Just don't feel tensed and all. Feel free to play around with any topic which is given to you or any calculation which you have, and feel free to link mathematics to physics. Okay, do a couple of good problems like this every day and then you are sorted for the next 60 days. All right. So while I hope you like this. If you like this, don't forget to hit the like button and share this video everywhere. All right. Hey, muscular. All right. While you're listening to this, definitely don't forget to crack IIT-JEE with India's largest platform, which is क्या हो सकता है बताओ? An Academy. Get the plus subscription using the code NSS1. The code is NSS1, and you get extra discounts and stuff like that. Awesome, awesome stuff. Awesome sauce चलेगा. You'll get daily live classes where you can chat with your educators, engage in discussions. देख यार एक बात बताता हूँ. यहाँ पे the chat I see once in like 5-6 minutes or time, stuff like that. तो मतलब बहुत slow हो जाता है. But in Unacademy plus subscription in the platform, you get to engage in discussions, ask your doubts and answer polls all while the class is going on. मतलब एकदम dynamic होता है. There is another show like this which is called the Night Out with Srikanth sir. Night Out with Srikanth sir. मतलब there I have little fun. ठीक है, it's not like this serious YouTube class की तरह मतलब problems नहीं रहेंगे. I'll just try to make you feel cool about stuff and all. Uh, yes. अच्छा, no code क्या change? Oh. Acha, so I think NSS1 is the code with which you have to log in or something. Yeah, I think even I heard that, not completely yet. But yes, not only that, you get live tests and quizzes, evaluate your performance with regular mock tests and quizzes, get detailed analysis on your performance. Structured course, all your courses will be structured will line with your exam preparation जो अभी 3 महीने में आने वाला है. So and you get unlimited access to all the teachers who've taught content here. So pretty cool. The cost of this is 38,500 for 1 year and 56,000 for 2 years. I think they've changed. Not only that, but the iconic subscription they've launched. This is they've also launched a new 6 month iconic subscription ka course. So this is pretty awesome. You will also get an expert guidance. You get a personal coach, which most of your students are missing right now. बहुत सारे लोगों को लगता है कि कोई टीचर का हेल्प होता तो मतलब मस्त हो जाता काम. तो यही दे रहा है अनअकैडमी, एन ऑनलाइन पर्सनल कोच जो तेरा टेस्ट एनालिसिस करेगा कि कौन सा क्वेश्चन जल्दी कर रहे हो, कौन सा स्लो कर रहे हो, कौन सा फास्ट कर रहे हो, कौन सा सही कर रहे हो, कौन सा गलत कर रहे हो, ऑल ऑफ दिस. एंड उसके हिसाब से तुझे एक स्टडी प्लानर देगा कि देख बेटा ये पढ़ पहले, आज इस वीक तो मेरी ये अच्छा नहीं करना कर रहे हो तो ये कर ले उस टाइप. हाँ द कोड मतलब या मैन आई नीड टू आस्क. I'll ask that right away. I'll have to change my code also. See, I'll try to change it. All right, and all benefits of Plus will be available to you. Now, IIT-JEE Plus, not only that, the iconic subscription have now been launched for 6 months also. For those of you guys who want to clear JEE this year, this is a wonderful option. मतलब 6 months अभी से iconic ले लो, काफी मस्त रहेगा. The cost of this is 38,000. All right. तो referral code NSS1 है तो use करना मत भूलना. Once it changes, I'll let you know. But 12 months course costs 65,000, which comes out to 5,470 rupees per month. Okay. So this is one, but if you use the code NSS1, you get it for 58,500, जो हो जाएगा 4,975 rupees per month, which comes down to 165 rupees per day, which is 55 rupees per physics, chemistry, and per subject. All right. So definitely it's pretty awesome. And for the cost of 1 or 2 years is 1 lakh. जिसमें NSS1 कोड यूज करोगे तो यू विल गेट इट डाउन टू 10,000 डिस्काउंट. यू गेट 10,000 का डिस्काउंट में हो जाएगा. ठीक है, तो डेफिनेटली गो फॉर इट गाइस. नाउ फॉर द नेक्स्ट राउंड, लेट्स गेट बैक टू दिस इरिडो प्रॉब्लम 1.171. ये क्या है क्वेश्चन? A shell is flying with a velocity v naught. Nice, not bad. I like the idea Siddharth Yadav gives, man. बहुत सही है. Pretty cool guys. All right, now a shell is flying with velocity v is equal to 500 meters per second, bursts into three fragments so that the kinetic energy of the system increases. N is equal to 1.5 times. The 1.5 times eta बढ़ गया. So what is the maximum velocity can one fragment obtain? तो तीनों particles identical हो गए. तो this is the best diagram to depict it. Initially, one m is having a velocity of some v, which is equal to 500 meters per second. तो इसके बाद ये कितना burst हुआ, one will have v naught and the others. So one thing I'll tell you guys here again, like in the first question, I will give you certain tricks भी नहीं बोलता हूँ. I want to say certain logical points with which we can approach in a shorter format. मतलब इसको थीटा वन थीटा टू v1 v2 v3 करके सॉल्व कर सकते हो, but that will become very lengthy. So what I'll do is I'll use the concept of symmetry. I will use partial symmetry. I won't directly solve of everything. I'm taking it will go like this for now, and I'll take this angle to be theta. So by symmetry, I will say both sides, both v1 and v2, both of these, जो भी ये fragment और ये fragment जो है, part A and B, let's say both A and B will move in identical trajectories. मतलब they'll move symmetric to each other. Move symmetric to each other. Only then the whole concept of maximum and minimum is based on symmetry. ax plus bx square plus c is maximum का concept कहाँ पे होगा? तो मतलब मिनिमम कब कब होगा? सिमेट्री के हिसाब से, यहाँ से इस साइड सिमेट्री के उस साइड सिमेट्री के, इसलिए माइनस बी बाई टू ए आएगा, माइनस बी बाई ए नहीं आएगा. सिंपल सी बात है. द सेम लॉजिक वर्क्स हियर ऑल्सो, that these both will start moving with same angle and same speed. Move symmetrically. Move symmetrically है. Symmetrically. Hence, I will take VA will be equal to VB is equal to V1 ले लेता हूँ. And the angle they make also I will take it as theta A will be equal to theta B is equal to theta. तो यहाँ अभी तक तो ये assumption से मैं काम चला लूँगा, ठीक है. Then I will change it based on whatever I feel later on. तो अब फर्स्ट में इसमें क्या क्या, what are the three things we know? The kinetic energy is increasing, ठीक है. So one thing I know, kinetic energy equation I can use, but I have to use kinetic energy final is equal to 1.5 times kinetic energy initial. All right, this is one thing I have to use, and the second thing I have to use is conservation of momentum. P is conserved because the force is internal. Whatever force which has done the blast, जो फोर्स जो ब्लास्ट कर दिया है वो अंदर से केमिकल जो एनर्जी है वो ब्लास्ट कर दिया. इट इज नॉट एक्सटर्नल. इज कंसिडर्ड बिकॉज फोर्स एक्सटर्नल इज इक्वल टू जीरो. देयर इज नो एक्सटर्नल फोर्स ओनली. सो मोमेंटम विल बी कंजर्व्ड. कौन सा डायरेक्शन में? बोथ इन एक्स एंड वाई. ऑलराइट, दिस इज वन कंडीशन एंड दिस इज वन कंडीशन. इन दोनों से देखेंगे वी कैन सॉल्व द आंसर. The first thing I will do is conserve of momentum in the x direction. Px is there. So what is the initial momentum? P initial will be how much? 3m into v. So 3m mass है वो v velocity से जा रहा है. And P final will be how much? This one particle is moving with v naught, which is the maximum we are going to find. Let's take maximum speed is v naught. ठीक है. P final is mv naught. ये mv naught वन पार्टिकल का है और इन दोनों का एंगल जो थीटा है, तो इससे क्या आ जाएगा? माइनस टू एम इंटू वी वन cos theta. The component of v1 along this direction ना, तो x डायरेक्शन का मोमेंटम कंजर्व कर रहा हूँ, मतलब x डायरेक्शन का ही वेलोसिटीज ले रहा हूँ. तो ये दोनों का x डायरेक्शन का कंपोनेंट्स कितना है? ये v1 cos theta हो जाएगा. v1 cos. तो इक्वेट बोथ ऑफ देम, व्हाट विल यू गेट? 3mv0 is equal to mv0 minus 2mv1 cos theta. तो इसको m सब कैंसिल कर दिए, तो व्हाट विल आई गेट? ये v है. v0 will be equal to 3v plus 2v1 cos theta. This is another very nice equation I got. This is the equation from conserving momentum in the x direction. Getting it? I hope it's clear. This is by getting by using conservation of momentum in the x direction. All right. चलो अब दूसरा करते हैं. We conserve momentum in the y direction. I will conserve momentum in the y direction. Y direction by symmetry यही हो गया ना. तो v1 into sin theta will be equal to v1 into sin theta. So the symmetry. This is only the concept of symmetry. And this only I got this concept. All right. Now the third thing we will use is conservation of by using energy equation. यहाँ पे conservation of energy use नहीं कर सकते हैं because the it's given in the question that it blasts and produces more energy. Cannot conserve, but we will use relation. तो ये relation कैसे use करेंगे पता करें. So the second next thing we will do is conservation of energy concept. Initial kinetic energy will be how much? Half into 3m into v naught v square. All right. And final kinetic energy will be how much? Half into m v naught square plus half into m into v1 square into 2 because two particles are having the same thing. तो इससे क्या आ जाएगा? तो so this is how much? Half into m into v naught square plus 2v1 final kinetic energy. And this is half into m into v square. So one thing we know the final kinetic energy is 1.5 times initial. As per question, final KE is equal to 1.5 times initial KE. Getting it? So we'll have to link this both again. So इससे क्या आ जाएगा? Final which is half m into v naught square plus 2v1 square is equal to 3 by 2 times half into so half into 3m half into m into 3v square into 1.5. ये जो 1.5 है ये मल्टीप्लिकेशन फैक्टर, ये ईटा है मल्टीप्लिकेशन फैक्टर, ये इनिशियल काइनेटिक हाफ एम विल गेट कैंसिल्ड नाउ. तो यहाँ पे क्या होगा? हाफ एम एंड हाफ एम विल गेट कैंसिल्ड. So from this we are getting a very nice simple equation now. We will get v naught square plus 2v1 square is equal to 4.5 v square. The second equation. ठीक है. अब फर्स्ट इक्वेशन में क्या आया? 3v v naught is equal to 3v plus 2v1 cos theta. यहाँ पे एक सिंपल सा लॉजिक बताऊं. This theta is not there in any other equation. So what is the other equation we had? V naught is equal to 3v plus 2v1 cos theta. तो ये जो ओरिजिनल इक्वेशन है इसमें cos theta can be anything, no? So from this whatever initial symmetry we used, even with the symmetry we are getting theta can be anything. Theta can be anything. So how much will it be to maximize stuff? To maximize V naught, cos theta should become 1. So theta will become 0 degrees. Okay, but simple. Now we understood that the other two particles will bounce back in the exact opposite direction. So from this, what did we understand? That the other two particles. So whenever you get this kind of situations where kinetic energy is being maximized, एक particle का velocity maximize कर, in that time the other particles will move exactly in the opposite direction. ये हमेशा काम करेगा. Opposite direction. That is when the entire energy from this particle from that particle will get split in the maximum direction. So the other particle moving in case maximum velocity is used. ये maximum velocity जैसे questions जब आएंगे ना तो ये situation जरूर आएगा. So that is what I want you guys to understand. So by using this logic now you will get to this point. Give me one more page guys. Now we can solve this both equations आराम से घर में बैठ के इक्वेशन को सॉल्व करो भाई. So what are the two equations we got? V naught square plus 2v1 square is equal to 4.5 v square. और दूसरा इक्वेशन है v naught is equal to 3v plus 2v1 3v plus 2v1. वैसे v1 को v naught by I can use this, no? v1 is equal to v naught minus 3v by 2. I'll apply this in 1. So what will you get? V naught square plus 2v1 square is equal to 9/2 v square. तो ये 2 साइड भेज दूंगा so that will become easier for me to calculate. 2v0 square plus 4v1 square, which is v0 minus 3v/2 whole square is equal to 9v square. हो गई. अब इस इक्वेशन को सॉल्व करो. 4 and 2 square will get cancelled because 2 square is 4. You end up getting 2v0 square plus v0 square plus 9v square minus 6v v0. v विनायक जैसा है ये is equal to 9v square. ये क्या हो गया रे? This 9v square and 9v square will get cancelled. This is never seen before. 9v square will get cancelled. So what are we left with now? 3v0 square minus 6v0 is equal to 0. इससे हो गया v0 is equal to 2v, which is 2 into 500 is 1000 meters per second. 1 kilometer per second. So 3 particles which are of equal mass, if it get divided, the maximum speed one particle can achieve is 1000 meters per second. मजा आ गया? So if you like it, definitely hit the like button, share this everywhere, make this viral, and let's have fun. Next. Okay. So this is Irodov problem 1.152. तो मतलब 4 प्रॉब्लम आज इनफैक्ट 5वां प्रॉब्लम है आज हमारा. So it is great going guys. मतलब 1 hour में we can solve 5 Irodov problems. So we can go for something like this, and definitely if you like this, share this video everywhere and make it viral. That is when I can know and I can continue with this with more eager, much better enthusiasm से continue कर सकते. Alright, 2 bars connected by a weightless spring of stiffness x. L not rest on a horizontal plane. A constant horizontal force F starts acting on one of the bars as shown in figure 1.40. Find the maximum and minimum distances between the bars during the subsequent motion if the masses of the bars are equal. So इसका natural length L naught है. So there are a few things I want you guys to understand. Natural length L naught है मतलब natural separation is L naught. तो L naught से ऊपर या कम होगा. ठीक है. तो maximum and minimum distances will be L naught. So maximum distance अगर पूछ रहा है, maximum distance between that masses will be equal to L naught plus x, where x is maximum elongation. Getting the point? अच्छा, स्प्रिंग कांस्टेंट x दिया है क्या? स्टिफनेस x दिया हुआ है तो मतलब इसको कुछ e मान लेते हैं. e मान लेते हैं. ऑल राइट. e is maximum elongation. Clear? So now we have to also use the stiffness constant k. तो इसको x ही मान लेते हैं. पहले stiffness constant को k मान लेते हैं. Let's take stiffness constant is equal to, ये सब सिंबल लास्ट में डाल देते हैं. पहले k यूज करेंगे, उसके बाद लास्ट में we'll put the x जो भी है वैल्यू है. So here one thing I want you guys to understand is that center of mass frame is best for this kind of situations. मतलब center of mass frame of reference से ये जो है, any spring problem, not just this kind of problem, any spring problem, you use this concept. अब ये सेंटर ऑफ मास फ्रेम से इतना सिंपल हो जाएगा कि मतलब अब सोचने बहुत सिंपल हो जाएगा सोचने की. So according to the center of mass frame of reference, the whole system is already accelerating. So according to the center of mass reference, the total acceleration of the system will be 0, because center of mass acceleration will only be acceleration of total system. No? So in center of mass frame, one thing we know, F net will be equal to 0. But then since acceleration of center of mass का acceleration है यहाँ पे, center of mass is accelerating. So this is a non-inertial frame of reference. So this is non-inertial frame of reference. पर यही बेस्ट सोल्यूशन है. नॉन इनर्शियल फ्रेम मतलब काफी लोग थोड़ा हड़बड़ा जाते हैं, बट डोंट वरी, आई विल एक्सप्लेन एग्जैक्टली हाउ टू सॉल्व नॉन इनर्शियल फ्रेम प्रॉब्लम्स टुडे राइट नाउ. तो नॉन इनर्शियल फ्रेम में It will be this is the center of mass is non-inertial frame, so you have to use something called pseudo force. अब मतलब काफी लोग इससे हड़बड़ाते हैं, तो डोंट वरी टू मच, आई एम गोइंग टू सॉल्व दिस नाउ, मतलब आराम से कर लो. So what I will tell is, let's sit at center of mass and solve. One thing we have to find out, acceleration of center of mass will be how much? It is net force by total mass, which is equal to F in this particular case by m1 plus m2. तो ये जो है सेंटर एक्सेलरेशन ऑफ द टोटल सिस्टम मिल गया हमें. ठीक है, acceleration of total system of center of mass is F by m1 plus m2. So now we will apply pseudo force on every body. Pseudo force will be equal to mass of the body into acceleration of center of mass in the opposite direction. तो मतलब यहाँ पे फोर्स बाहर ऐसे चल रहा है, तो मतलब एवरी पार्टिकल विल एक्सपीरियंस फोर्स. नाउ सूडो फोर्स विल एक्ट इन द ऑपोजिट डायरेक्शन. ये ईस्टवर्ड जा रहा है, so this will act towards west direction, or I can also say minus I cap. ठीक है, तो now I'll apply the pseudo force on every particle which is there. अब फ्री बॉडी डायग्राम खींचो, एक स्टेप में आंसर आ जाएगा. m1 is experiencing a pseudo force which is equal to how much? m1 into acceleration of center of mass, which is m1 f by m1 plus m2. और दूसरे बॉडी पे स्प्रिंग यहाँ पे है, तो दूसरे बॉडी पे भी सेम फोर्स लगना चाहिए. तो सूडो फोर्स आई विल पुट अगेन लाइक दिस, m2f by m1 plus m2. पर यहाँ पे एक एक्सटर्नल फोर्स भी है, ये तो मैजिक की बात, तो मैजिक की बात मानना पड़ेगा सिर्फ. So of this total thing, if I simplify, I will get a wonderful and a beautiful relation here, which is going to be one step solution for us. एकदम यहाँ पे हो गया, एकदम यहाँ पे फोर्स जो है F माइनस एम टू एफ वन, तो हो गया m1 f by m1 plus m2. इस साइड भी सेम फोर्स हो गया, m1 f by m1 plus m2. So voila, ekdam wonderful, beautiful solution for you guys. I hope you it's clear from this. So once I get this, it's a single step process. Now I can find out maximum expansion will be double of this. No, maximum expansion, I will use the concept of energy, not energy conservation. The total work done will be zero. So यहाँ पे compression and total work done by this both. Let's take this compressing by x, expanding by x. Energy method. I will say at maximum expansion also both of them will be relatively at rest. At maximum expansion both m1 and m2 will be at relative rest. So everything you know work done is frame dependent, right? एचसी वर्मा का डेफिनेटली यार, डेफिनेटली करूंगा. आज मैं एरिडो का किया, बट एचसी वर्मा लास्ट 10-15 प्रॉब्लम्स इवन आई वाज थिंकिंग कि आई शुड डू दोस थिंग्स. तो पहले इसमें फोकस करो. एक बार सेंटर ऑफ मास फ्रेम में एक बार थोड़ा और एनालिसिस करेंगे. तो सेंटर ऑफ मास फ्रेम में एक बात हमें पता चल गया कि क्या, कि बोथ द नेट फोर्स ऑन द सिस्टम इज जीरो. सो इसमें क्या समझ में आ जाएगा, वर्क डन बाय टोटल सिस्टम, वर्क डन बाय सिस्टम इज जीरो हमेशा, बिकॉज देर इज नो एक्सटर्नल फोर्स. वर्क डन एक्सटर्नल इज जीरो, क्योंकि जो भी एक्सेलरेशन, जो भी एक्स्ट्रा फोर्स है, जो भी एक्स्ट्रा वर्क करेगा, वो सब सिस्टम के सेंटर ऑफ मास के फ्रेम में एडजस्ट हो जाएंगे. So in this center of mass frame, the work done external will remain zero. So we can simply start solving total kinetic. So at maximum compression and maximum expansion, it will have क्या? It will have zero kinetic energy. So initially it has zero kinetic energy एकदम initial frame में, और maximum expansion में, maximum compression में भी zero velocity, zero kinetic energy. तो इससे हम let's take it's elongating by x. तो अब इस solution को simple एक step में solve कर देंगे. Now we know work done externally is zero. So let's take it elongated by x. By x. तो वर्क डन बाई फोर्स कितना हुआ, वर्क डन बाई मतलब ये फोर्स का वर्क डन कितना हुआ, ये दोनों जो फोर्सेस है उसका वर्क डन विल बी वर्क डन बाई एक्सटर्नल द सूडो फोर्सेस, वर्क डन ऑन ईच ब्लॉक, टोटल ब्लॉक्स will be equal to m1 f by m1 plus m2 into x. Getting it? This will be equal to half k x square. तो यही हो जाएगा, दिस विल बी इक्वल टू द एनर्जी स्टोर्ड इन द स्प्रिंग. So by because velocity of all the system is zero, so work done by all external forces will be equal to change in potential energy plus change in kinetic energy. This is equal to zero, so we can write it equal to change in potential energy. बस हो गई बात. तो इससे क्या आ जाएगा, x will be equal to 2m1f by m1 plus m2 into k. तो k के बदौलत we can write this whatever that value. वंडरफुल सॉल्यूशन हियर फॉर यू गाइस, आपके लिए ये है. हाँ एग्जैक्टली, टेंशन भी जीरो वर्क करेगा. वो फर्स्ट क्वेश्चन में दिख गया है. गिरीश गौरव, गुड गुड ऑब्जर्वेशन. तो बहुत सारे जगह में जीरो वर्क का कॉन्सेप्ट यूज हो जाएगा इफ यू यूज द राइट लॉजिक देयर. जैसे कि इस सिस्टम में मतलब तुम इफ यू जस्ट गो इमेजिनिंग इन नॉर्मल सी, काफी मुश्किल हो जाएगी इक्वेशन सॉल्विंग. बट इफ यू आर सिटिंग इन सेंटर ऑफ मास इमेजिनिंग, बोथ विल गो एक्सपैंड आउटसाइड कम इनसाइड, एक्सपैंड आउटसाइड कम इनसाइड, एक्सपैंड आउटसाइड कम इनसाइड, ऐसे ही चलता रहेगा. ठीक है. तो दिस इज द लॉजिक गाइस, ये एकदम आराम से हो जाएगा. हाँ, तो ये तो एक्सपेंशन है. तो व्हाट इज द मैक्सिमम सेपरेशन पूछा है क्वेश्चन में. मैक्सिमम सेपरेशन अब पूरा नहीं हुआ दोस्त, मतलब पहले ही लिख चुके हैं हम. फर्स्ट पेज ओनली वी रोट दिस सेइंग द नेचुरल सेपरेशन इज एल नॉट, सो मैक्सिमम डिस्टेंस विल बी एल नॉट प्लस एक्स. समझ में आए. सो दिस इज वेयर यू हैव टू बी वेरी वेरी केयरफुल गाइस. जेई एग्जाम में भी ये काफी बार होता है. You solve the whole thing, but small thing in the end, if you miss out, no, you will miss out on one addition or something. The entire mark चला गया. बहुत सावधान रहना. तो इसलिए ये टफ प्रॉब्लम्स में भी हमेशा याद रखना कि पूरा सॉल्यूशन करना पड़ेगा. That's it. So maximum separation will be L naught plus 2m1f by m1 plus m2 into this kind of symbol. Okay. मिनिमम क्या होगा, मिनिमम इसका माइनस होगा, तो प्लस माइनस कर दूंगा, मैक्स मिन हो जाएगा. राइट. when m1 is equal to m2 करके एक और भी ऑप्शन दिया. when m1 is equal to m2, ये तो बहुत इजी हो जाएगा. when m1 is equal to m2, what is the maximum expansion now? Expansion will be L naught plus 2m1 by m1 मतलब 2 हो गया, तो f by. That's it guys. So I hope you liked this. That's all for today's slide show. आज मजा आ गया. चलो फिर मिलते हैं चलते चलते. Stay tuned for tomorrow also guys. Tomorrow I'll have Hitsi Varma problems for sure. Okay. We'll discuss about any problems you want to have in today's daily night show, late night show. Okay. Definitely रात को 10:30 को आ जाना. और any comments you want to drop in, drop the comments in the comment section here or in the night out with Srikanth sir. All right. We will discuss what to do, and tomorrow let's meet at same time and have awesome problem solution. Until then, bye bye.